There's actually a way that we can improve problem 45 jump game 2. I've solved this problem before, and we can improve that code. So back then I used pretty much a while loop and two for loops. Now we can reduce that. We will have a variable called near, a variable called far, and they both start at 0. Near far is like the range of our jump length, right? So yeah, there we go. And we can have a variable called jumps, or let's call it count, so it is similar to our last approach. All right, and while our far is still not is still it hasn't reached the last index yet, we keep jumping, right? So let's say for I and I equals near and I is less than or equal to far I plus plus. And what we're gonna do is we're gonna say uh we have a furthest, right? We have oh okay. We have a variable called furthest. Let's set it to 0. And for each for each step from near to far, we would try to find the maximum steps that we can jump. So max furthest and nums I plus I. Uh-huh. Furthest nums I plus I. Yeah. So after this for loop, we'd find like the first furthest range that we can jump, and so we will update our near to the next index, our far to furthest, and our count would increase. So we just need to return the count at last. Let's see how that runs. There we go. So as you can see, far. Let's revise the code again. Oh, after we submit it. Okay, let's submit it and then we'll revise the code again. Fabulous. So you can see that while far hasn't reached the end, we keep jumping, and each time we find the furthest range that we can jump by going from every index from near to far in our jump range. We find the furthest range that we can jump from, furthest range that we can jump, and then we update our our new near and far. So near becomes the next index from far, and far becomes the furthest location that we can jump to. And each step is a jump, so we increment our count variable and we return the count. That is good. All right, see you guys in the next video.